Hello students. In last video lecture we studied post-wall dilution law for weak acid and after that post-wall dilution law for weak base. In this video lecture we are going to start our new point, the point that is based on mainly JEE and NEET and qualified exams, because this point is not included in this year's syllabus. So it is mainly JEE and NEET based point. So it is the applications of, point name is applications of post-walled dilution law, post-walled dilution law. Now let us see the formula of post-walled dilution law for weak acid and weak base is equal to alpha is equal to under root Ka upon C or Kb upon C for weak base. Alpha is equal to under root Ka into V. These are the two formulas, or Kb into V for acid and bases respectively. These two formulas is used and derived by post-walled dilution law. Now this formula is mainly used to calculate monobasic acids or monoprotic acids. This formula is mainly used for monobasic acids or monoprotic acid. The word mono means single, that is basic, that contains OH group. Okay, आता याचा अर्थ समजून घ्या. मोनो means single, basic means single OH group, acid means H plus. The monobasic acid, it means one H plus acid is combined with only one OH group or one OH minus ion, called as monobasic acid. बरोबर. असं पण आपण म्हणू शकतो पॅरलली की असं ऍसिड की जे 1H प्लस आयन देतं, असं ऍसिड की जे 1H प्लस आयन देतं, त्याला म्हणायचे मोनोबेसिक ऍसिड. मोनो मीन्स सिंगल, बेसिक मीन्स OH ग्रुप किंवा OH मायनस आयन. ओके, सिंगल OH असं कन्फ्युज होऊ नका. मोनोबेसिक ऍसिड, बेसिक मध्ये ऍसिड कसं, बरोबर. सिंगल OH आहे त्याला अटॅच व्हायला एकच H प्लस लागणार ना, म्हणून म्हणजे असं ऍसिड की जे 1H प्लस आयन देतं, 1H प्लस आयन डिसोसिएट करतं, इज कॉल्ड एज मोनोबेसिक ऍसिड और मोनोप्रोटिक ऍसिड. ओके, mono means single, protic means one proton, that is 1H plus. Okay, the acid which contains or which dissociate one proton is called as monobasic acid. Simply as I am telling you, the acid which dissociate only one proton, proton means 1H plus ion, called as monobasic acid. So what are the examples of monobasic acid? Let us consider HCl. It dissociate only one H plus. This one H plus combines with one OH minus only, na? So that's why it is called as monobasic acid. So HCl, HF, HCN, HBr, HI. These are the few examples regarding monobasic acid. Okay. Now, in case of monobasic acid, generally we have to calculate Ka, the dissociation constant. We have to calculate dissociation constant because it gives only one H plus ion. And regarding base, only H plus ions. So we have to calculate. Point to be, remember that. Please remember that. I am writing again. I am telling you once again. What is the equation for Ka? Equation for Ka suggests here 1H plus Cl minus divided by HCl of mass action. If concentration of H plus ions is greater then value of Ka also greater. Want to be remember that. Okay. So if I this H plus ion is increases, the concentration increases, value of K increases. This is the how to calculate Ka in monobasic acid. Okay. Like that monoacidic base. Like that monoacidic base. Okay. So monoacidic means mono means single. Okay. So I am not confusing you. The base which donates one OH minus. The base which donates one OH minus called as monoacidic base. Okay. And the acid which donates one proton or one H plus ion called as monobasic acid or monoprotic acid. Okay. So what are the examples you already know? KNaOH, KOH, LiOH, etc. I am not writing all of the examples, you have already known. So in that way, so monobasic acid and monoacidic base. So only one H plus ion, this compound only gives one H plus ion, and monobasic acid HCl, HI, HBr, it gives only one H plus ions. So we have to calculate Ka for acid and Kb for base. So K and Kb is calculated or dissociation constant. अल्फाचा उपयोग K आणि Kb हे जे आपण काढतोय ते हे जे फॉर्म्युला आहे ते जनरली K काढलं की तो इथं टाकता येतोय, बरोबर. K ची व्हॅल्यू टाकता येते आणि K ची व्हॅल्यू डिपेंड कोणावर असते? डिपेंड्स ऑन कॉन्सन्ट्रेशन ऑफ H प्लस अँड डिपेंड्स ऑन कॉन्सन्ट्रेशन ऑफ OH मायनस. ओके. सो इथे व्हॅल्यू टाकली की अल्फा मिळतो. पण हे जनरली मोनोबेसिक ऍसिडच्या बाबतीमध्ये आणि मोनोऍसिडिक बेसच्या बाबतीमध्ये हे दोन फॉर्म्युलेज आणि दोन म्हणजे तसे चार आहेत, बेसचे आणि ऍसिडचे वेगवेगळे बरं का, उपयोगी पडतात. बट वी हॅव टू कॅल्क्युलेट इफ उपयोगी पडतात. इतरांच्या बाबतीमध्ये सुद्धा उपयोगी आहे, पण त्याच्यासाठी तुम्हाला Ka काढायला पाहिजे, बरोबर. मोनोबेसिक ऍसिडसाठी जनरली आणि मोनोऍसिडिक बेससाठी वापरतो. पण व्हॉट हॅपन इफ डायबेसिक ऍसिड, दॅट इज डायप्रोटिक ऍसिड, एकापेक्षा जास्त असेल तर डायप्रोटिक ऍसिड अँड ट्रायप्रोटिक ऍसिड. Triprotic acid. What happens if the substance having or the acid which having more than one proton, like that in case of H2SO4, H2CO3 carbonic acid. Okay, this contains two protons. This dissociate which gives two protons. On triprotic acid means that I am taking H3PO2, H3PO4. H3PO4. It consists, it dissociated three protons. Okay. So what happened? How to calculate Ka? Because these dissociated three protons. Okay. This dissociated three protons. This dissociated two protons. So I am not जर 3 प्रोटॉन दिले आणि 2 प्रोटॉन दिले तर K आपल्याला डायरेक्टली मिळत नाही. त्यासाठी एक फॉर्म्युला बनवायला पाहिजे. सिंगल प्रोटॉन सिंगल OH असेल तर डायरेक्टली आपण K आणि H हे डायरेक्टली प्रोपोर्शनल आहे, म्हणजे तिथं डायरेक्टली टाकू शकतो K ची व्हॅल्यू. पण या केसमध्ये नाही टाकू शकत. मग त्यासाठी काय करायला पाहिजे? आपल्याला एक रिएक्शन बघायला पाहिजे. ओके. कुठलं एक्झाम्पल? लेट अस कन्सिडर एक्झाम्पल रिगार्डिंग H2SO4. Example regarding H2SO4. So H2SO4 I am dissociated in two steps because HCl is dissociated in one step because it contains only one H plus ions. So original reaction for that it contains twice H plus SO4 minus twice H plus SO4 minus. Okay. Now if I am taking this reaction or convert this reaction into two steps, then we get step number first H2SO4. If I am losing only one proton in one step, so what will form? It converted into H plus what is remaining? It is HSO4 minus, HSO4 minus, because hydrogen contains positive charge and this HSO4 minus contains negative charge. Total charge is balanced. Okay, if hydrogen loses, hydrogen dissociate, the HSO4 is remaining. So HSO4 acquires negative charge. Okay, this is I'm calling it as Ka. That step is called as Ka1. Ka1. Okay. Now, then step number 2. Step number 2 is called as HSO4, like A to B, B to C, that is equal to A to C. Okay. So step number 4 consists HSO4 minus. Okay. It dissociated it as H plus plus SO4 minus minus. H plus SO4 minus. Okay. This is how to write Ka twice in second step. Dissociation constant in first step, dissociation constant for second step. Now we have to balance that. Our overall equation will suggest that. Suggest that. काय प्रमाणे HSO4 HSO1 opposite way आहे, so it is deleted. Then it will form, let's see, H2SO4, which gives H plus that is equal to twice H plus SO4 minus SO4 minus. Like I am thinking it is like Hess law. Okay, so it is the original equation suggests the value of Ka. Okay, so value of Ka can be calculated by using or dividing these equation into number of equations. So this equation number first Ka, this equation number second, that is Ka2. Overall equation is correctly balanced because H2SO4 twice H plus SO4 minus. This is the original equation. Dissociation constant for this dry protic acid is equal to K. Like I am saying, it is 10 or whatever will be. So this equation I am converted into two steps. Number first, H2SO4, it loses one proton, it gives HSO4 minus. So that is the step number first. I am denoted it as Ka. So HSO4 minus, this is our B. It loses one proton, so it will form SO4 minus. This is our step number 2. Then HSO4 minus and HSO4 minus are in opposite side, so it will be cancelled out. So H2SO4 remain as it is, H plus twice H plus SO4 minus. This is Ka1 and this is Ka2. Then our formula, general formula for calculating Ka is equal to, please remember that, general formula for calculating Ka is equal to Ka1 into Ka2. General formula for calculating Ka is equal to Ka1 into Ka2. If there are 3 acids, H3PO4, so it will be into Ka3. Okay. So these are generally called as monobasic acid or monoacidic base. This is then after diabasic, that is diprotic. In case of diprotic, triprotic, these are commonly called as polyprotic acid. Diprotic, triprotic, असं जास्त आपण नंबर वाढवू शकत नाही. मग टेट्राप्रोटिक म्हणत नाही. मोनोऍसिडिक जे असेल, मोनोप्रोटिकला तेवढं आहे तसं म्हणायचं, मोनोप्रोटिक. डायप्रोटिक, ट्रायप्रोटिक पासून जे कोणी असेल त्यांना एकदम कॉमनली म्हणायचं असते पॉलीप्रोटिक ऍसिड, कॉमनली कॉल्ड ॲज पॉलीप्रोटिक ऍसिड. ओके. आणि आपण मोनोप्रोटिक ऍसिडच्या बाबतीमध्ये काय अडचण येत नाही, कारण की एकच प्रोटॉन असतो आणि एकच OH जे काय असेल, त्यामुळे ते काय जनरली अडचण येत नाही. याच्या बाबतीमध्ये मग के आपल्याला सेपरेटली काढावा लागतो. कॉमनली के काढण्यासाठी तो फॉर्म्युला आलेला आहे, K1 इंटू K2. ट्रायप्रोटिक असेल तर K1 इंटू K2 इंटू K3. पॉलीप्रोटिक अजून असेल तर K4. ओके, अँड सिरीज मस्ट बी गो ऑन. So I am proving that K is equal to K1 into Ka2. So what is the value of Ka1? What is our Ka1 equation for Ka1? I think I want to write it once again. So H2SO4, it will form H plus HSO4 minus. And then second equation is HSO4 minus, it will give H plus SO4 minus. Then I want to write the Ka by applying law of mass action. By applying law of mass action. It will form product upon reactant. This is the product H plus in bracket HSO4 minus divided by H2SO4 divided by H2SO4. Okay, then K2 is equal to, this equation will get H plus in bracket SO4 minus divided by HSO4 minus. Okay, now let us compare K and K2. We will see there is a K into K2. So I will convert it H plus in bracket HSO4 minus divided by H2SO4 into K2, value of K2 H plus SO4 minus SO4 minus divided by HSO4 minus. Now I think in common HSO4 and HSO4 will be cancelled out. Okay, so it will form then remain H plus and H plus. Then H plus H plus, that is equal to H plus to the coefficient of twice. Okay, and SO4 minus divided by H2SO4 divided by H2SO4. Okay, now I am convert K into K2. I am calculate. I want to prove this formula is really happens. K is equal to K into K2. I want to prove this formula is really exist or not. So I am taking the value of Ka into value of K2. It clearly suggests that HSO4 minus and this HSO4 minus are cancelled out. Okay, now H plus into H plus, that is H plus to the power 2, and SO4 minus it remained as it is because HSO4 minus and HSO4 minus are deleted, divided by H2SO4. I am calculating K into K2 is equal to, this is our calculation, K into K2 is equal to this. Now I want to make equal, so our original reaction that is H2SO4, which gives twice H plus SO4 minus. I am expressing it as Ka. Then I am dividing this equation into two parts, K1 and K2, and then K1 into K2, the answer will be here. Okay, now the original, I want to write K for this equation. K I am writing here, so you will clearly understood that K, product upon reactant. What is the product? Product is H plus power change in concentration of species. त्याची power डोक्यावरती द्यायची. Then bracket SO4 minus divided by H2SO4 divided by H2SO4. This is our original equation and is the original K value. Okay, then after that this original equation is divided into two parts. Number first K1 and number 2 K2. Then after that I am writing this formula to calculate K for in case of diprotic acid, or that is I will say polyprotic acids or polyprotic bases. So this is the formula I am right here. K into K2 is equal to K. I want to make equal. So I am equaling K. What is the value of K? And this is into value of Ka2. So overall result will be K into Ka2 this. And original result of Ka is equal to H plus to the power 2 SO4 minus divided by H2SO4. Let us compare these two equations. You will clearly see that equation, this equation and this equation. You will clearly see that K is equal to K into K2. This equation clearly indicates Ka is equal to K into K2. So this is how to calculate the K in case of polyprotic acid. In case of monobasic acid or monoprotic acid, nothing problem with at all, because we have to use general straightforward formula given by Oswald dilution law. Okay, but we have to calculate, the term is calculate. Original formula तर आहे, original formula, this is the original formula for weak acids and weak bases. Okay, weak acids and weak bases. But in case of weak acid, in monobasic acid or monoacidic base, okay, means the substance which contains 1 H plus or which dissociate 1 OH minus. एक H plus किंवा एक OH minus दिला तर K calculate करायला अडचण नाही, K calculate करायला अडचण नाही. But if there is diprotic acid, triprotic acid, I am literally conveniently say polyprotic acid or polyprotic bases. Okay, then we have to calculate K manually. You have to calculate Ka manually by using formula K is equal to Ka1 into Ka2, because in case of polyprotic acid K can't be given directly. Point to be remember that. So I am going to prove the formula, that is K is equal to Ka1 into Ka2. Or sometimes there will be 3H plus ion or 3OH minus ion, it will be Ka3. So these are the two general formulas you must have to write here. K is equal to Ka1 into Ka2 into Ka3. Okay, now then you have to write formula for base. Kb is equal to Kb1 into Kb2 into Kb3. This is the formula for calculating dissociation constant for weak base and weak acid in case of polyprotic acids or polyprotic bases. Polyprotic bases. You have please note down this formula. This formula you will use in JEE NET and many qualified exams. So please take a screenshot of this formula or note down this formula. In this lecture we are studying the Oswald dilution law for weak acid and weak base, the applications of that, applications of Oswald dilution law, weak acid and weak basis. Hopefully you have understood this lecture. In next video lecture we will discuss about next points. Thank you.